Okay, let's get started. Would you do me a huge favor? Could you shut that door on your way out? It just holds down on the air traffic. All right, so last week I talked about a midterm. We have no midterm for this course. I don't know what I was thinking. So for this course we have 4 projects and 6 assignments. There's no midterm exam. In fact, if you go to the bhacker.com website, you'll notice that it may or may not be working properly. I'm having, actually, believe it or not, this is a topic for a database class. I'm having issues with the database. It's not really the database that I'm worried about on this particular case. It's the computer that's running the database is overheating. So my bhacker.com website keeps going down. So long story short, if it goes down, you see it, can't resolve the address error. Some SQL message comes up and spits at you instead of a graphic page. It's not my fault. It's the database server that's acting funny. I think I'm going to fix it tonight. This is actually kind of a true lifetime story that can show you everything impossible that you could possibly do to the database to make sure it's running properly. It doesn't actually take itself outside and blow off the dirt from the fans. Sometimes you actually have to take the housing off of the computer and see what kind of dust has accumulated inside of it. Because you know what ended up happening to me was like sometime in the middle of last night, it got too full of dust and dirt. And the fan stopped working and pieces of the components are burning out, it's frying itself up essentially. So I took the cover off. It's resting, but it's still intermittently working, not the way I want it to work. So it keeps rebooting itself. So long story short, if you have problems getting to this site, don't worry about it. In terms of what assignments we have for this particular course, and I hope it's actually working now, which is great. It probably just rebooted fresh. So just so that we're all, including me, on the same page, I've got the syllabus here. And the syllabus doesn't mention at all anything about a midterm exam, which I mentioned last week. The midterm talks about, the syllabus has final exam, CSLO essay, projects, and homework. So let me talk about the CSLO because I did prepare that for today. And so you don't have to worry about a midterm. The other classes this term are having take-home midterms, so you don't really miss out on anything. If you feel like you got ripped off in your midterm, don't worry about it. I have put up here this thing called Spring 2011 CSLO. Oh, it's working too. Wow, we might be in luck for a short period of time here. If you go out on the website, you'll see 2011 CSLO essay. That one is brand new and it'll be uploaded into the ITU EMS momentarily. If that site doesn't work, you can also go to this site, which is bhacker.com/exams, where I've also made available, and this applies to the other classes as well, a list of midterm exams, CSLOs, new stuff that I've just put up. This is it was sort of a backup for me for today because I want to go over these items, and if I don't have access to them, it's going to be a problem. But I'm going to leave it up because you guys might want access to them as well, and the TAs can probably use this as an easier way as well of getting the information. So let me talk a little bit about the CSLO and what's that all about. And it's not due until the very last day of the course. And, oops, hold on one second. That's the midterm for the last class. That's the lecture for today. All right. Make this a little bigger so you might be able to see it. All right, if you go to the link, can you take a look? This particular item is only worth 10 points of your total course grade. Not that big of a deal, really, if you think about it. But a lot of the work in this particular class is creating the SQL queries, creating the entity relationship diagrams, and all of the other projects and assignments that you're going to be doing throughout the course. If you're familiar with the concept of the CSLO from previous terms, don't worry, it's different. Completely different this term. What you have for this particular class is what's called a course student learning essay. It is still a writing assignment. In fact, this is really the only writing assignment you have for this particular course, because everything else you're doing is going to be entity relationship related, or SQL related, or database related, hopefully somehow. And this assignment allows us to kind of help you or give you an opportunity to improve upon your English writing skills. Because this is a graduate level course, and hopefully one of the objectives of what you're doing while going to school is to improve your communication skills and learn how to write in a technical manner. And so this is your opportunity for this particular class. And if you are taking any other class with me, this is the only class that doesn't have a midterm. The other classes do have a midterm, just as a side note before I forget to clarify that. But we don't. We have this course student learning essay. What is it? It's worth 10 points. You select one, and this is the same format for my other classes, so if you just sat through the Java, you're going to be bored. But the topics are different, so you've got 5 different options. What you're doing is selecting one of the 5 options, and I'll go through the options for you. And you're going to write a 2 to 3 page double-spaced essay on your selected option, or your selected topic. You're not writing 5 essays, you're writing 1 essay. It's 2 to 3 pages, it's smaller. The ones for the other classes are 3 to 5 pages. That's because they don't have all of the projects and the assignments. Because if you haven't looked at it yet, there's a lot of work for this class, actually. There's 4 projects, 6 assignments. That's a lot. This is small. This is double-spaced. So 2 pages is really 1 page, single-spaced. You know, not to call it trivial, it is not quite as intense as the other classes. It's only 10 points. Not meant to be the same length, so you don't have to follow any of the expectations that we had in previous terms about any of the CSLO related stuff. You must include 3 reference citations, which means I wanted you to do some research. So you go out, and most likely your paper's probably going to be about 3 pages double-spaced is one thing. It's going to be hard to do it all in 1 page, single-spaced. You're probably going to end up going into 2 pages, I suspect, probably fairly easily. I want you to go out and find some research, do some research on these particular topics, put some references in there. The references could be Oracle, the Oracle website. It could be, it can be anything. This class is not quite as strict as some of the other ones because, are they watching a movie? Wow. You may not necessarily be able to find books, journal articles, or things of that nature to reference. So this is going to be a little easier in terms of the expectation. 3 would be good if you could find those. In terms of your research you're going to perform, you're going to gather some information, you're going to use it into the paper. You're not going to cut and paste. So I've actually seen this already in previous terms where students have cut and pasted and then provided a reference citation. But without any rewording or anything, you just cut and paste and you just stick it in there. And then underneath you put like a little URL where you found it, which isn't quite the concept I'm talking about. I'm talking about writing a paper in your own words using your own abilities to formulate ideas, and then use a reference citation like you would in a formatting language, formatting style. So you might be wondering, what style do I use? You can use the MLA, you can use the APA, you can use a little brown book, you can use a variation of whatever it is you may be familiar with. And if you're not familiar with anything at this point, I'd go with the APA. If you go to www.a as in apple, p as in Paul, a as in apple.org, O-R-G, you can see all the specs on the American Psychological Association writing style. And I know you're not writing a paper that's for psychology class or sociology or something of that nature, but you can use the same format. What I mean by the format is that I'd like you to present a formal-looking paper. So it's double-spaced, it has 2-inch margins, or you can find out all these specs. And try to follow the spec. Put a little title page on it. It's only 2 to 3 pages long. It's not a huge writing assignment. But what I'm grading you on is your original thought and your writing abilities, which means spelling is important, grammar is important. The way you present your ideas is important. The way that you have found research and have used the research in the paper. It's all about the paper, and it's all about your writing. Your content's going to count a little bit, but all of the projects and all of the assignments are assessing your technical abilities. This is assessing your writing skills. and your comprehension and being able to put something thoughts into words, I should say. So your paper must reflect your own writing and cannot contain portions of cut and pasted information from the internet or from other sources. So all papers will be processed through a program called turnitin.com, which is a plagiarism checking thing. This is the first paper that you're writing that has been issued. In fact, each term we're going to have, you notice it was called Spring 2011 CSO. Well, then we'll have Fall next time this class, and Spring and Fall. Different versions of everything, so that there shouldn't have been any previous history of any assignment that was ever created. But if there was, it would be in turnitin.com. You guys are populating the database, which means your papers are going to be the first ones that are coming in on your topics that you're doing this on. However, the database also contains papers from other sources outside of ITU. It's a service, so it should hopefully be fairly comprehensive. It's a plagiarism checking tool. We're also going to use a couple of other tools as well as the internet to make sure, because one of the main criteria in terms of the grading and the assessment of this particular paper is that you wrote it yourself. You don't want to see any recycled work from anybody else. It's an individual assignment. Everyone does their own paper. And it's your opportunity to practice your writing. If, for example, don't give me individual work, you give me somebody else's assignment, then you're not going to get any points for it. But lucky for you, it's only worth 10 points. So you can get an A- in the course, because that 10 points from 100 points gives you 90 points, which is an A-, which means you're not going to get an A in the course if you get 0 points on the CSLO essay. Not that big of a hit, because most likely you're going to struggle more with some of the other assignments in this course, which are more labor-intensive than this particular essay. But if you do fall into that category, you don't give me your own work, or you don't turn it in, you're going to get 0 points for it. If you get 0 points for it, that's what's going to end up happening. There's no redos. There's no makeups, do-overs, or anything like that either. You only get one shot to do it. So hopefully you'll do it correctly. And it will actually reduce your score by half of a grade percentage, so it's worth paying attention to. So let's take a look at some of the topics. You're selecting one and only one to talk about. And we have 5 to choose from. So the first one is, what are some of the social, ethical, administrative, and policy issues surrounding databases and their use? So provide an overview of issues using examples and/or case study information. So basically, what you need to do is kind of research ethical, social, and what I've done here is actually try to highlight the words that were important. So I've got, not highlight, but I've got them in a different font. I've got the words social, ethical, administrative, so kind of different font. All right, so these are the issues. So there might be many different types of issues. You can actually kind of focus this on a particular type, like e-commerce or something. Using databases with e-commerce transactions, or let's say you want to talk about the social issues of sharing information in databases. It doesn't have to be a technical paper. It can be on a subtopic of this major theme that is being presented. And so you don't actually have to approve all of your major changes to this. As long as it fits into this category or one of the other categories, you're set. But this is pretty wide open, because you could talk about a bunch of policy issues and things of that nature. So when it says case study information, you can find a company and use that to create your own case study kind of environment, or you can actually kind of look and use a real case study that you might find. If you go through some of the database books, you're never going to find a case study on anything. If you go through some of the other like information systems technology type books, software engineering books, or even the internet, you might actually find some case studies to reference and to look at. But what you want to do is use some examples and or case study, which means tell me why is it using an example not safe for whatever it is you're talking about, or what would the policy issue be, or what would the ethical or social issue associated with whatever it is you're discussing. And make sure that your example is associated with what you're talking about. And that'll actually help you get your page length, actually, because that'll provide you with the information that you're going to need, essentially, to talk about. So the second one, number 2, And feel free to ask me any questions as I'm going through this if anyone has any questions regarding any of that. And I'll pause at the end for some questions as well. Number 2, I've got highlighted the words web databases. So this one, the whole question is describing how web databases are used to provide businesses an application benefit. So looking at web databases, how they're used for application development in business environments. So you can write with that particular topic or theme, and here's some sample. You don't have to answer all these questions. It's kind of an idea giving you some hints about what I'm talking about for this particular category. What web applications are benefiting from the use of databases? What security or other database-related issues does the internet create? How could these issues be avoided? And you might notice that this one here, it says web-related issues, and well, that's all question number 1 is issues. So your essay might fall into 1 or 2 category depending upon how you're focusing it and what you're doing with it. But the idea is to come up with your own kind of concept that you want to talk about in terms of that particular area. Number 3 is how to design a database application. You can focus on the design component of it, which might actually kind of be an easy option for some of you who have no idea of the business approach to it. Maybe you just want to talk about database design. Using an example business scenario. What I don't want you to do is kind of take and something that we've done in the projects or the assignments where you're given a problem description and you turn it into a database. That's like a redo. It's not really an essay. It's kind of a redo of an assignment is what it kind of seems like. I don't want you to do that. I'd rather have you write out thoughts and perspectives. So explain the design steps in detail, starting from the textual description of the application, ending with a set of database tables that can be used for the application. So don't go out and give me some text for a description, give me ERD diagrams, and then give me a list of tables. It's not really objective. I'd rather have you explain more. If you're going to do that, great, but your paper is going to be longer than 3 pages because you're going to need to add to it descriptions about the design process. Because what I'm looking for is your writing ability, a demonstration that you can actually write out what these processes are, how this database is actually being created, stuff like that. So. Number 4, why use Oracle? That's a loaded question. Why use Oracle versus, and this is your compare Oracle with another database question. So you can actually kind of say, well, what features, what advantages, and this actually will kind of give you an opportunity to research Oracle. If you do that, most of your references are probably going to come from the Oracle site, or the Java, it's going to come from an Oracle-related product or service. So as a kind of a sample questioning, what are some of the Oracle products, services, features that exist out there? Describe in detail what makes the Oracle a good database, why people use it, and focus on the pros and cons of using the Oracle as a database management system. You might actually kind of take a tangent on that question and talk about, let's say, the Oracle reports or Oracle developer or the forms generator, forms tools or something. And it will give you an opportunity to kind of research, investigate Oracle products, essentially, and come out with some information and report on and describe in an essay format the information that you found and discovered. So. The last one is kind of an interesting one, and I thought I'd throw one in for the technical people who want to write more technical stuff, who want to actually learn a little bit more about query features and things. The last one wants you to say describe essentially what is meant by query optimization and how is it performed. So first of all, you got to figure out what query optimization is. I'm going to talk about it a little bit later in the course. I haven't even talked about it yet, but it's coming up actually kind of soon. And you want to explain how query optimization works, explain in detail some of the query issues, patterns, or scenarios in which query optimization would make some sense. Some of the common query optimization techniques that are out there. That would actually kind of be an interesting one for anyone in the class who kind of wanted to have a little bit more of a background, kind of discover on your own query optimization tools and procedures. So each one of the questions, 1 through 5, kind of gets at a different theme. And if you walked in late, you only pick one. You pick one of the 5. You're not doing all 5. Your paper is a writing paper, which means I don't want source code, I don't want SQL, because I can totally see someone taking that query optimization and rewriting queries, and or doing something mathematically, or drawing out data structures or trees or something of that nature. Don't do that. I don't want pictures, I don't want drawings. What I want is your words, because you're actually being graded as an essay, as a writing assignment. And spelling, grammar, punctuation is important. This is your opportunity to improve your writing skills as a graduate student. This would be kind of a nice thing, especially from graduating from an American university, to have some sort of a writing ability, I would hope, in English. You all speak English, but even natural-born people out here have problems writing, so it's not a bad assignment for everybody, regardless of what skill level you're at. So, questions about the CSLO essay is not due until the very last day of the course. And just to reiterate, for those people who came in late, this will be in the ITU EMS probably sometime during the week. It's not there yet. Not due till the end of the course. All assignments, including the projects and the assignments outside of this, as well as this, everything has to be uploaded into the ITU EMS by the very last day of the course. Assignments cannot be emailed to TAs. TAs do not have the ability to upload assignments themselves. Only you can. You're the only one who has access to your accounts. The only way you're going to get credit for anything is if it is uploaded. So, unfortunately, if you have problems, you need to report the problems. Actually, they're pretty close to actually finishing up. They're upgrading everything, so there's been a few minor little problems, but it's getting better. So if we start now, hopefully by the time, the first week in May, which is really the end of the course, hopefully most of the problems will be resolved. The other noteworthy piece of thing to get away with, or to walk away with as well, to remember is that the final exam is an in-class final exam where you do have to show up in person and take the exam with a pen and a piece of paper, and physically show for it. I cannot allow you to take it remotely. I've already fed off a couple of emails of people saying, I live in this country, I live in this state, I live this area. Doesn't matter. You still actually have to come to the university to take it. As we get closer to the end of the term, we will be sending out final exam schedules. The TAs will be sending it out to you to let you know on which particular day, which particular time your assigned group is going to be taking, and it's probably going to be by the alphabetical of your last name, alphabetical order. If you don't like your group, don't panic. We can make arrangements to have you take it during a different group. We can also have arrangements for you to take it on a different day. So we will make it happen, but you do actually have to come to campus and take it in person. And if you don't, you'll get it incomplete in the course. So, questions? Yes? Oh, option number 5, query optimization. Ideally, I would prefer that you talked about Oracle, considering that this is an Oracle database and administration course. However, I don't mind actually if you want to work with another database. It would be nice if you mentioned like maybe a comparison to say, hey, this is how MySQL works with this, so this is how another database works with it. Oracle doesn't even offer these features or something, or it'd be nice to have Oracle kind of, but you don't have to. In fact, if you're wondering as well on any tangents that you might want to take on any of these questions, it's not necessarily the tangent, it's not on the content, it's on your writing. This is a writing assignment, so I'm looking to see if you can explain yourself. So, secondary is the actual content. I don't really care how many lines of code you've given me or SQL queries or anything. It's your writing that counts. This is sweet, by the way. Any other questions about the CSLO essay? I'm going to drink my sweet Snapple, the new Snapple commercial. This is sweet. Actually, it's kind of like soft cough syrup sweet. Whew. All right. No more questions? All right, then we can all go. I'm just kidding. All right, lo and behold, where are we in this course? We have finished SQL. I've given you Bootcamp SQL, 3 or 4 different lectures on it. I have given you everything you ever wanted to know about entity relationship diagramming, sort of. I gave you enough to be dangerous. The first couple of projects deal with the concept of entity relationship diagrams and taking those diagrams and turning them into tables. I can't really tell you anything more about that outside of you actually doing some hands-on work with it. The only way you're going to learn it is kind of like programming. The only way you're going to learn how to take a problem scenario. Can you please keep it down in the side over there? Thank you. And obviously, sign the roster as it goes. I thought it sounded like a parrot as it's going around. All right. The only way for you to learn entity relationship diagramming is to actually do it, which is why we have so many projects and assignments that are related to it. Right now, you should be done with the first couple of homeworks, and you should be done with the first couple of projects. We are at the midpoint, actually, which is why I have the midterm for the other courses, but we don't have a midterm for this class. Now what we're doing is kind of switching gears, and I'm going to be talking about a bunch of, to preview the next second half of this course. It's all primarily Oracle related, Oracle specific. I'm not going to teach you how to use Oracle as a tool. This is not an application program kind of course. This is a concepts and theory course. So what I want to do is introduce you to Oracle features today, starting with what's called PLSQL, which is a strictly Oracle procedural language that is actually still being used. A little legacy at this point, but it is actually still has a place, and it's not a bad thing to know about. I'm only going to spend today on it. The next time we're going to talk about normalization and taking and applying normalization concepts. Then I will be talking about reporting tools, form generation tools, web tools, a bunch of different topics. So this is our first kind of selected topics in Oracle sort of thing. And the problem is I have to kind of like bounce around in a lot of different areas to kind of give you an overview of a lot of different information as it pertains to the system. So. And I know this is 61 slides, but don't worry about it. I will go through it at the speed of light because, again, it's kind of like learning a programming language or scripting language. I can only introduce it to you. You can't learn everything by memorizing what a variable is or what, the concepts don't work that way. So what I want to do is let you know that this is lecture 5A if you want to download it. And it only covers PLSQL, and it only applies to Oracle, which means you can't do this in other database programs. And you really only will probably run into a problem or have to apply any of this if you're working with a legacy piece of code or if you're working in an environment that still uses it. PLSQL is very old, actually. And can we keep it down? Because I don't want to yell over you in the back. I don't know what happened to my TAs back there. Can we do some crowd control? The far corner over here is a little loud. We're gonna bring out a big hose soon. And that would be cruel to the students, wouldn't it? It might be not a bad idea in the summertime. Actually. Take a squirt gun or a hose. And it's the only way I can reach you back there. All right, back on focus here. What is PLSQL? PL stands for procedural language, and it works with SQL. You're wondering, well, why in the world why am I talking about this today? It's actually kind of interesting. It's the only thing like it on the market, and that's why it's still on the market. All right, so we know about SQL, hopefully. And at this point, you should know what it means. You should know how to write a few sentences. You should be armed and dangerous. You probably know how to get to it. Use the SQL Plus window and in an Oracle environment. Other environments, you'd open up a terminal window, and you would type sentences in there, SQL statements, and those statements would be executed, and you'd get text that comes back out. Command line interface, essentially. PLSQL sort of works like that, except it combines a scripting language with an SQL language. The SQL language is the same. The plus part of this whole scenario, and it works in a PLSQL Plus window, they don't normally label it that way. They just call it SQL Plus. The plus part of the SQL Plus are utilities like PL, programming language, procedural language syntax, that takes and complements the SQL statements to give you full scripting capabilities inside of that SQL Plus window and also in command interfaces, command-based programs. Doesn't work well with internet applications. Doesn't work well with application interfaces, but it does actually have a GUI interface to it, GUI library and add-on tools. Works with a bunch of different modules and packages as well. But bottom line, this was originally generated so that programmers had the ability to actually create a program and use SQL all at the same time all together. Because now what we have, 99.9% of all the applications on the market, we have SQL to talk to the database. Then we have the application over here, which is a totally different language, JavaScript, PHP, whatever it might happen to be in. And all this application does over here is send SQL commands to the database. You know, this person's got to send one, we all know this, person's got to send one to log in, after it gets logged in, do an update, do a query, take the result set, parse the result set. There's a lot of back and forth going on between the two. PLL SQL puts it all together, puts it all in one application, makes it accessible, makes it very feature-rich for command line type of applications, which is how it primarily started, which is how it's still being used, actually. So what are we looking at? It uses detailed instructions. It processes statements sequentially, procedural. I mean, it's the oldest language you could possibly come up with. Combines SQL commands with procedural instructions. So it makes it more powerful. Used to perform sequential processing using an Oracle database. Does not work with other databases. This is an Oracle created language that works with Oracle. So why do we want to bother with a programming language? We know SQL, right? But SQL doesn't do everything. SQL allows you to talk to the database, but it doesn't support variables, doesn't support the use of memory, doesn't support the application development process. We can't put a prompt out to the user and say, hey, enter the first name, enter your last name. We don't have anything associated with the user interface, with the design of the application. It's just a query, it's just talking. So we can essentially take PL-SQL, combine the two, and then we have the concept of variables. So the variables have to follow the same naming convention as Oracle itself, as Oracle naming standards. You can't use any reserved words, obviously, because you can't use like begin, number, built-in data types, and stuff like that. So you have to make the words sort of descriptive in nature as a kind of a common thing. Using lowercase letters and separating words with underscores. This is a little example on the bottom here, current student ID. Why do we want a variable? I can keep track of data that we've received from the database, and we can manipulate the data and then make some changes to the database. We're still using this language to communicate with the database. We're just adding some application level support to it. So when we declare variables, what I'm going to do is kind of run through the features of the language. And when I said this slide starts like 60 slides long, but I'm not going to cover the whole thing. I'm going to skip a lot of the syntax, a lot of the rules, a lot of the here's how you program in it. That's for you to investigate when you download the lecture and look at it later, if you ever have a need. Not that I didn't know what it is, know what features it has, whether you'll end up actually ever write. Has anyone actually written in this language before? That's probably a good question to ask. No one will probably ever write in this language sitting in this room. But you might actually run across a piece of code and wonder, what in the world is that? And it'll say, oh, written in PL SQL. Really, why? You know, and then you figure out what it was used for. And sometimes, in rare occasions, it's just like any other scripting language, you might actually have a need for it. Small little utilities get written in this all the time, actually. And then it makes nice little glue between applications with PLSQL. It's like the red hat, the rabbit that someone pulls out of their hat and says, it's broken, we can't interface it. Nope, here you can do it now. This is the solution. So, alright, it's a strongly typed language. All variables must be declared prior to their use. So the syntax for declaring a variable is kind of very similar to other programming languages. So we got a variable name, a data type, declaration. So, but it's a different order. So we have current. We have this variable we created, current student ID. Well, now we're going to take it. We're going to call it number 6. So it follows SQL. This is the interesting part. The language was written for SQL developers. There are people who only know SQL who don't know programming languages. So it's one of the easiest languages for a non-programmer to learn and to use. So it became very accessible in the beginning to non-programmers who needed to write programs to work with the SQL. So, because we have here, any other programmer would put the data type before the name of the variable. Here, it's just like writing an SQL create table statement. We have the current ID, number 6. Here's the other interesting thing, is the data types. They're identical to the Oracle data types. So what do we do when we write, a program in Visual Basic or ASP.NET or something? We connect to the database using a database object, and we pull data from the database. We get what's called the result set that comes back. And we take the result set and we parse it out and we assign the values to variables. Common. Almost everybody who writes an interface to a database ends up having to go through some procedure like that. Only problem is the data types are different. And anyone who's ever worked with data types, and especially with financial applications and things, knows that any small little rounding, any small little truncation, precision, anything is going to cause a fluctuation in results. Like this float may not necessarily be equal to this float. Vice versa, in terms of the data representation. Because the data variables, the data types, used for variables in a language is defined by the programming language. So if Oracle is defining a float and Visual Basic is defining a float, if it supports floats, I'm pretty sure it does, the two definitions might be completely different. Float's not a float everywhere in every language. We all know that because we have errors that occur. So do you want 1,000,000.5 to be rounded up to 1,000,000.6? That's a couple of $100,000 difference. Might be a significant number in terms of rounding, in terms of precision. So people started using PLSQL to do data manipulation on the data, to add a percentage to it, to do calculations on the data in the database, to pull it out, to apply the calculations, then translate it into, so it's an interface to the SQL to interface the data into a compatible float that's equal to this float over here, to that double over here. So we don't have any problems with money. We don't have any problems with rounding, stuff like that. So the language supports all of the different database, specifically all of the different database types that are in the table. This is probably going to be an outdated list because it was written off of a previous version of Oracle. Now we have slight variations to it, numbers, scalars. We still have those large binary objects. We still have those. In terms of the scalar variable, where in the world can you find a programming language that's going to support a variable character too? Or something that is Oracle specific. So, and that's the interesting thing about databases, they all have their own format for the data type, the date, the time, the information that's stored in that database. When it comes out of the database, it turns into information that's represented in other formats, in other programs. It's not 100% equivalent. When you want precision, you go with a language like PLSQL. Interfaces exactly to it, takes it, copies it out into a variable character if that's what it was. I think I've driven that point home. So, composite data types. Yeah, it actually supports a record. It actually supports a table, a variable array. So we have reference multiple data elements such as records. So how else can you say, give me the row as a data type? Now, what we do is we take the information out as a result set in Visual Basic, Java, any language that you're working with, C++, and you're making it into a different representation. You don't have a record. Actually, Visual Basic, believe it or not, Visual Studio.NET actually has a record concept, but there is a translation, there's a conversion of the data. It's not in a native form. But we can actually create data that's represented in terms of how it's represented in the database, and it supports database types like rows, views, joins, tables together. We can support that view of the join. It comes out in its natural form. Referencing data types, we reference a data item. So we can assume the data item, the data type of the item. So we can say, we can get the type, which assumes the data type of the field, which is a field. Data type row assumes the data type is the entire row. So we can pull the entire row, using PLSQL, we can pull the entire row of a database, treat it like a row, go through each one of the fields, treat it like a field, and actually just work directly through a programming language interface with the data. and through its natural. So. And here's some PLL program structure. So these programs look like, it actually kind of reminds me of Pascal, actually, with the begin and the end. So it's really old. It's a very old procedural language. It's very Pascal-y looking, which was long before C in the old days. We have declare. We're going to declare a program. Variable declarations. Begin. Some program statements. Exceptions. We have built-in exception handling, which is not bad. And so that's pretty much the program structure that we're looking at. And the program lines. So the lines of code may span multiple text editor lines, made word wrap. We end each line with a semicolon. So it's kind of like C, C++, and other modern languages. Text is not case sensitive. A little different. Some other languages are case sensitive. But here we actually, we don't worry about that. And I forgot to mention before, we can actually reference data in the table without actually querying it or pulling it out. We can actually say, give me, look at first name B. You can actually run a query. So thinking back to the concept, if you're familiar with C or C++, we've got like what, pointers. We can look at dynamic memory. We can load something out in memory. We can actually get it and manipulate it right there at the memory address. We can do that with PLSQL. But the memory we're looking at is in the table. It's the table. Instead of pulling it out, a copy of that information, say, how many classes is B. Hecker teaching right now? And pulling it out, instead we go to the table and we reference directly that row, the column in the table for B. Hecker, given query information, and we manipulate it right there. So we don't have any copying moving around. Very, for the same reasons why it's effective in C or C++, because it's, we don't have to copy a bunch of data from here to here. Working with a large database, do we really want to copy the whole table and work with it? Just go to the table directly and work with it. It's faster. So PLSQL is actually kind of used a lot for efficiency. You don't have to query the table. You just go to the table, go to the row, go to manipulate the data right there and change it right there. So it's a miracle language. So anyway, so comment statements, kind of like C or C++, where we got the comment blocks here, and or we have the single comment lines, starts with 2 hyphens, just kind of like the dashes, but now we have hyphens instead. Or we have the the antique-looking C comments, the asterisk and the line. We have the arithmetic operators, very kind of similar to other languages. Multiplication, division, addition. This is where I'm going to kind of skip through because you don't really need to learn about the syntax of it. You don't have to write. There's no programs. There's no assignments in this class that have you write anything in PLSQL, so you don't have to worry about that either. The assignment is different. This is actually very like Pascal-y, like the colon and the equals instead of the equals. But it's student name. You're going to equal to something. So. Which is interesting because you can actually kind of do an equals and reference the column so you don't have to do an update. So it actually saves you on SQL statements. If you think about it, sometimes people have to write an SQL query to go query it and then an update statement to go update it. Which if you actually do the query optimization assignments, or if you pick that option on the CSLO essay, you'll learn all about, I have more optimization stuff to show you later on. But that's not really efficient. It's time consuming. Every time you query that database, it's time consuming. Unless you have a database that doesn't have anything in it. And why have the database? Most databases are huge these days. So. Okay, so displaying output, we can actually set environment variables. When we display output and we get input, it's very much Unix. It looks like Unix, smells like Unix. It isn't, but it has that kind of flavor to it. So normally we use normally PLSQL is used with other Oracle utilities such as forms or reports. Interesting thing. So you start looking at some of the Oracle tools, and then you start looking at, and you start using, it's all based on PLSQL. The syntax is all PLSQL. That's Oracle's language. So, you'll end up having to use it eventually if you don't use it in the command line interface. If you start looking at the forms and the tools and stuff. So you're going to learn to use PLSQL in the PLSQL Plus window is a basic, the old-fashioned way of doing it because we don't have access. Otherwise, I'd show it to you in some of the tools, but I don't have the 200 or 300, $2,000 or $3,000 to buy the developer of the tool. It's a very expensive toolkit. It's not free. But you can use PLSQL in Windows. So in the command line interface, and this is now bringing light to this SQL Plus window interface. It is not just an SQL window. The Plus tells you that it has buffered memory, it has a history, it has a bunch of features that aren't necessarily apparent to the average user. Here we have a set environment where we're going to set the environment output. We're going to set the size of the buffer. We're going to set the size of the buffer itself. We can actually purge it. We can print the buffer. We can manipulate the buffer. I believe, no, actually next week's not normalization. Next week I think I'm going to show you the SQL Plus window, and we're going back to SQL Plus next week for some small joins and stuff. Some examples, but I can't remember. It's either that or it's the following after normalization. I don't remember my own order. But anyway, long story short, the window has a lot of features to it. That's interesting to note. So the command to output is to dbs_output.putLine. It's kind of like working with DOS, if you think about it, or working with Java with a system out or something. The language has a built-in feature for I/O. In fact, it has a built-in feature to take in libraries as well. So what most people do in terms of writing small utilities is they'll put them into a text file. Load the text file into the window, run the text file. And what you're doing when you load it is you're putting it into the buffer space. So you want more buffer, so you just create a bigger buffer. And the output can be redirected. So you have an SQL Plus window. It is running stuff just like Linux or Unix. You can redirect that output, send it to an application that's running on the server, send it to a website, which is how a lot of the web monitoring tools are actually done that work with the database. So you can get, current usage, peaks, errors, and people logging in, who's using what, when, usage log information, can all be redirected through PLSQL from an SQL interface to a status web page. In fact, it's kind of pretty easy to do that, actually. So if you copy the code from Notepad, you use a backslash and it executes the code for you. We have date conversion functions that are written in the SQL language, in the PLSQL interface, that convert your input into the exact same format as what's stored in the database. So you can do correct comparisons and correct updates on the database without having to use SQL to do it. So the language will also convert to date to number to character. Character string functions are in there as well. Concatenate two strings together, separate things out. Because really, if you think about what we're doing with this PLSQL, is we're manipulating the database. We're manipulating information in there. And if you think, we're not going to write full-fledged applications with this. We're just using it as a tool to manipulate the data. We want string concatenation. We want functions to convert, things of that nature. The language is very feature-rich on database-related functionality that doesn't always exist in other languages. And it's actually made so it's easier. So the assignment of, let's say, a right trim, a left trim, an upper, convert it to lower, which is what we'd actually be doing if, for example, we were running a query. So let's say we have a shopping cart, and we go to the database, and the person has entered their name all in caps, and it's stored in the database all in caps or something. We would take that information out of the database, have to do a check on it, and then have to go, well, what is it, and convert it and make it look nice on the page, for the invoice or whatever. If we're going to actually do that. There's some applications that don't care. If you've ever bought anything if you've ever sold anything on eBay, you see the customer's information come out, then the first character of the name's not capitalized, and the whole thing's in lowercase, and it looks like a typo, but it came directly from the database, wasn't manipulated at all. That's what the person put in there. So it doesn't fix it up. If you want to fix it, you can use PLSQL to actually fix it up before you deliver it to the web application that's displaying it. So it takes the work away from the application level and puts it back on the database. You can also use it to maintain and to clean up the contents of the database. So you have a character space of 30 for the first name, but the person only put 5 characters in there. You can truncate the rest of it. So every time you pull the data out of the database, you don't have to do a trim on it from an application level. You've already cleaned it up. So there's trimming white spaces from the front or from the back. All sorts of different utilities that you can run through PLSQL commands to clean up the database, essentially. Copy stuff, move stuff around. In string to see if something is in a string. Searches a string and looks for matching substrings to return a starting position. Look for duplicates in the database. All sorts of different functionality for that one. Then we have character string functions, substrings for characters, exact number of characters from a starting point. Given a point, tell me where is this from 1 to 5 or something. So let's talk about debugging. Very primitive debugging, but it has built-in exception handling, which is kind of interesting. Because if you think, it's not really a compiled language either. However, you can compile PLSQL code, and it gets compiled into some of the developer tools that are sold separate outside of Oracle. In terms of syntax error, it does not follow language guidelines, causes PLSQL compiler errors. Example might be a misspelling, a reserved word, using a function incorrectly. In fact, what ends up happening is when an error is encountered, the language will continue, the script will continue. It's kind of like the way SQL is executed. If you've got an SQL, a bunch of SQL statements you put into a file, you load the file, you start running it, it runs into an error, it just continues. Oh, I think someone's talking back there and it's really irritating me. Oh, good. Whew, I stopped. Oh, yeah, shut that door, too. I don't know what movie they're showing next door. I kind of want to sit in on it. Maybe we should see movies. What are we going to see movies on? I don't know. Anyway, the history of Oracle. That would be fascinating. All right, so what ends up happening is a line-by-line procedural kind of process, and so if something fails, it just moves on to the next line, So logic errors, programs compile correctly, but doesn't give out correct, doesn't give out the correct output, then you have a logical error problem. So, in terms of locating and correcting syntax errors, it's kind of hard, which makes the language not very user-friendly. We don't have like Visual Studio.net or something where we've got, or even like an Eclipse environment where it's going to highlight the source code in colors and give us report, tell us about warnings and stuff like that. It's a primitive style of scripting language without any kind of warning or interface. So we have to do it sort of manually. And this is just some suggestions on the slide here about isolating the line, commenting out the line. That's just basic knowledge in terms of what goes on. In terms of fixing it, identifying the output variables, testing out, and this is the interesting part actually in terms of PLSQL and its value. Even if you don't write an interface to it, even if you don't write a script at all for it, and it's used for scripting, by the way, then you can use it to test the database. A utility that has like 2 or 3 lines in it. To take something and see what the value is, cross-check it against another value, and see if a trigger's working, or see if something is compatible or consistent. So it's a great way to actually kind of talk to the database in sort of a different level. So you're not really interested in the data in it, but you're checking the integrity of the system, checking the constraints and stuff. Which you can actually do because you can copy things to variables and then compare, Out of 7 queries, we got the right answer 5 times. We got the right answer 6 times. And keep track of the history of those queries and stuff. So. Alright, the language deals with null values. Whatever programming language out there you're going to get not only speaks the same language of the database, has the same identical data types, but also is familiar with the null logic. Because as I remember, it's a threefold logic. Three route logic. It's either true, false, or unknown. And so the logic that comes out of in terms of a query result from a database is different than what you'd expect in a programming language interface. So until a value is assigned to a variable, the value is null. So you can actually work with nulls in PLSQL and use it kind of in the same similar fashion as we work with nulls in the database. Performing an arithmetic value on a null always returns null as the value instead of an error message. So we can actually take the value from a PLSQL procedure and it's null, and we don't have to run a bunch of checks in Java or C++. Is it null? Is it greater than 0? Is it less? we can actually just forget all of that stuff. It's a lot easier. We can just say, you know, what is it, and treat it and add it, subtract it, and do everything with it, and not have to worry about any side effects because it's null. You know, so. Advice: always initialize variable values, otherwise your variables do end up being initialized to null by default. So. PLL SQL, we have, and this is kind of the boring part again, I'll kind of flip through. What you'd expect in C or Java. Very similar, in fact very compatible. We've got our if, end, else, if, end, if, else, end, if. In fact, this looks very Visual Basic-ish, because it kind of follows around the same kind of guidelines as regular old QBasic or some of the earlier versions of BASIC when this language was actually created. The if condition, the else if condition, the else. Our comparison operators are fairly standard as well, with our greater than, less than. In fact, it supports more C-like, I think, Visual Basic. When evaluating a null condition in the if-then structure, interesting. So if the condition evaluates null, then it is false. Because it's not true. If it were true, false or unknown. So the false and the unknown comes out the false. So it makes conditional kind of expressions easier. It makes looking and performing that type of procedure. And how can a condition evaluate to null? It uses a Boolean variable that has not been initialized, and then it'll be null. So we can actually come out with a condition that is null in terms of a Boolean evaluation. It uses any other variable that has not been initialized. It'll come back with that. And if we don't have an initialized variable, then it means it should be null, essentially. If we didn't get anything out of the database, then it's null. So it works with the same kind of logic as you didn't put anything in the database, you're going to get a null value in that column for that row. So using the commands and the programs, it supports the data definition language, the data manipulation language, and also transaction control. So we can use PLL SQL and run a rollback, or run a commit, without actually having to send a command to the database. And hopefully the command will make it. We can actually set up transactions. So that's why, going back to the kind of the original, when I was starting to describe what this is really used for, accuracy, control over that database, and the glue between different applications. So you can actually run some consistency checks, run some more precise calculations, and then commit the data through the PLL SQL script, not rely upon a broken Java program to do it for you. Because that Java program that you're writing, or that C++ program, or whatever program you happen to be using as the front-end application, all it knows how to do is connect and send a script. Depending upon what time the script shows up, given the network connection issues, given whatever might be going on, it might receive part of it, might receive all of it. We can run something, a PLL SQL kind of script at the database level to check to see if the transaction, if all components were successful, and then if they were, commit it. If not, roll it back, send a message back to the application. So we can actually kind of ride in between the application and the database and do a lot of high-level management kind of work in terms of transaction processing and control. Create logical transactions with control. And but in terms of the data definition, changing the database structure can be used in PLL SQL. We got no in terms of the administrative level commands. We can run an update. We can run a which most people think in terms of the definition you want to use, and the only way you can use is through SQL. So you can actually run an SQL script through PLL SQL that's going to perform a create, an alter, a grant, or revoke. So in terms of the concept for why that is the case, we don't have a PLL SQL command to, let's say, create or alter a table, because it's part of the Oracle security. So if we want precision, we want safety, accuracy, we're not going to allow a PL script that someone can put a virus in there, let's say, and drop all the tables and create. So it's kind of a level of protection to some of the stronger admin to DLL commands that cannot be performed through PLL SQL. So, and it's higher level, kind of Oracle coming in and saying we're not going to allow you to risk the integrity of our database from an application point of view. Interesting to know, however, you can run a create table and delete table, alter table, drop table, truncate table, anything you want through an application interface. I write a Java program to delete everything in the database. But you can't do it through PLSQL. Well, who said you can do it through, well, somebody else? So that's the interesting thing. When you write a program that runs with Java, Visual Basic, whatever, there are no rules. In fact, you can log in with the admin password and log in if you wanted to. It's up to the developer of that application to impose the rules. And usually, they don't use an admin password for a website to connect to a database. They're going to use some higher level, something that's a little bit less, that's more restrictive, less control over the database, that's not going to give them privileges like an admin would have. Otherwise, you're just opening up yourself to some extremely easy hacking to go on. Because database passwords and logins are a dime a dozen. In fact, you can go to websites and actually get them. So it's like getting passcodes, or what I call those, key codes for application installs and stuff. All right, let's go with loops. We can do loops. So we have a pre-test loop, post-test loop, same kind of loops you're familiar with in other programming languages. And we actually use the word loop. You loop through something, and if it doesn't happen, loop while, loop exit when, the while loop, the numeric for loop for such and such. And it's, again, going back to kind of a pre-modern day language. It's more Pascal-y looking, because it's like for this variable, counter variable, in the starting value to this ending value, loop. So, really old-fashioned. Supports cursors. We don't get cursors in modern day programming languages. In fact, we don't get cursors unless we're working through this SQL plus window. What is a cursor? It's a pointer to the memory address location, is what I was talking about before. It's called a cursor, not a pointer, but it is a pointer. It's used the same way. The dynamic memory isn't really memory that the computer is using. It's a table memory. It's where the table's being stored, or where the view is actually being stored. The cursor just allows us to get at the actual data instead of the variable that's pointing to the data. So it's the same thing as a pointer. Contains information about the SQL command in the PLSQL plus command window, called the command's context area. So we have the context area, which is the running memory of the program, and then we have the area in which we have our cursor, and the cursor is the database information. So in terms of the cursor concept, and actually Oracle, I believe, is the, don't quote me on this one, but I believe it's the only database on the market, unless MySQL has this capability yet. I'm not quite sure if MySQL supports cursor behavior. They were like one of the first people to come out with this, and I believe that they may only be the still remaining company that's doing this. Here we have the data server memory. We're going to talk about memory table spaces and how this memory is organized in a future lecture coming up. But this concept of the cursor, we have the context area, then we have the active set. So in non-PLSQL environments, we run a query, we get the query back, we have a result set. And we work with the result set as if it were a string, a data string. Here we can work with the cursor, which is the result set, because the database knows what it got back. It has the information right here. Why translate it? If you work directly with the cursor information, you're true to source, essentially, instead of copying here, copying there. We have two different types. We have implicit and explicit cursors. The implicit cursors, they're created automatically. You don't even have to do it. So you can explicitly create a cursor, or you can use one automatically. And when you use it automatically, that's what you're doing. When you run a query in that SQL window, you get the cursor automatically. It's temporary memory. Think of it that way. It's temporary memory. It's holding your result set back, holding all the information back. That's basically supporting the rollback and the commit, actually, because it's keeping track of the history of everything. It's keeping track of all the cursor information, all the temporary space for the manipulation. So the implicit cursor is created automatically every time you use an insert, update, delete, or select command. Does not need to be declared. Can be used to assign the output of the select command to one or more PLSQL variables. So we're not doing an assignment, we're talking to the cursor. So can only be used if the query returns one or more records, obviously. If we don't have anything, you can't use it for anything, it doesn't get created. It's kind of like there's no result set to come back with. Here's the implicit cursor syntax. Now this is the part that it's hopefully going to bring home the concept. Select field 1, field 2 into variable 1, variable 2 from table space. So where search condition that will return a single record. So this is interesting. This is why we use PLSQL. Long lecture short. We can talk directly to the cursor. We don't have to go through any manipulation. So if we did this, we'd take, and you know how many options there are to accidentally assign a value to something else, or not keeping track of what value came out of what query. Common actual problem we end up with in terms of building web applications and stuff. You run a query, the results come back. Is it the last query you ran? I don't know. Is it the query that goes to this customer or that customer? Are we getting the right results for the right activity? Is this old? Is this cached? Because we like to cache information when we do applications as well. Did this come from a text file? Should we update this file? Is it updated? All this translation from point A to point B. There. We've ran a query. We've done a select and we're into variables already. We did SQL query to assign values to our variables, essentially. And now we're using the variables as if they were part of, they came from the database, essentially. So without actually having to do any type of, integer I is equal to 0. Do a query, take the value that comes out of the query and assign it to I, which might leave itself open to mistakes. That talks directly to the database, minimizes the risk of there ever being any problem with the translation or the conversion of that data. Which is why, for heavy-duty mission-critical, must be precise. That's the answer. Explicit cursors, let's declare one on our own. So you must declare, using the declare section of the program, you create a cursor. And the cursor can be assigned to the output of a select command to one or more PLSQL variables. So we can save it, instead of it going away after the query, we can save the information and use it again. It can be used if the query returns multiple records or no records at all. It happens anyway because we declared it. So it's going to exist, it's going to have a 0 value, it's going to have null if nothing was assigned to it. So to use an explicit cursor, we declare the cursor, we open the cursor, we fetch the cursor results into the PLSQL variables, and then we close the cursor. So it's kind of an interesting concept. It doesn't exist in any other programming language. You can't do this in Visual Basic Java or anything else. So here's the heavy-duty programming statement, not too bad. And the declare has to show up anyway as part of the program structure. Cursor name is select a statement. You put a statement in there, select statement, it goes in there. So you're running a query, so what does this do for you? You can take query results and compare them with each other without having to write a nested query. So all those people who didn't like the nested queries, we did a subquery inside of a query, and sometimes we had 5 queries going on. This allows you to make it more human-like. So instead of doing all that, you can run all these queries, put them in cursors, and then use the cursors with itself. So you have essentially no more nested queries if you don't want them. So you can make up for complexities in SQL language. You can make up for using PL as a programming language kind of interface to it. So you don't have to do it in SQL, essentially. Opening up an explicit query, you go open cursor name. Fetching the records, you fetch the cursor into a variable. So you're taking it out of the cursor, you're adding it to putting it into a variable, just as the same as we did the implicit technique. And then we close the cursor by going close cursor name. So processing an explicit cursor, well, we're probably going to use a loop for it. This is why the language supports a looping. And I didn't go through all the looping syntax, but we can loop, go to one next, do a for loop, a while loop, or, a counter loop. Anything that's supported in regular modern day programming languages is going to be supported here as well. So, and here's a loop that just fetches out the cursor name, puts it into a variable name. Something out of the, takes it and adds it to a variable so we can use it. And here's a for, what was this one? This is a loop. Next is like a while loop, I guess. And this one would be the for loop approach. It takes any number, well, for names in cursor, loop through. And don't be concerned with the programming language syntax. I'm just showing you the capability, essentially. So let's go back to the concept of using the reference data type in the explicit cursor processing. Because really, if you think about it, what are we going to use this language for? You know, for things, functionality that's not supported in any other programming language. I mean, otherwise, you'd write it in Java, essentially. You're writing something else. So referencing data types themselves in the explicit cursor processing is one thing we're going to do because we have the data type. So we could declare a row type reference variable. So we have a variable that is of data type row that represents a row. And we can take that variable and use it in a programming language kind of style and manipulate the contents of the row and treat it like a row in the database. So the referencing the row type, we have a reference variable name dot database field name. So we take and we associate the database field name through a dot notation from the row, because one row might have many different columns, many different attributes associated with the row, and we get it through a dot notation. And the structure is built in for us automatically. The data structure is supported. It's kind of like if you were in C or C++ and you created a structure or a class that had data members in it. But here's for you. It's automatically created for you. So the data type supported. So with some explicit cursor attributes, we have things that we can run. And in terms of not found, returns true when no rows are left. Found, row count is open, is closed. That's just a small list. That's kind of an example of attributes that you can run on the cursor. And the table is also supported. So you can take a table and load it into a variable data type and work with the table from a programming language perspective. So the data structure that contains multiple data items that are all in the same data type. Each table item has a key and a value. So we have key 1, Shadow, 2, Dusty, Sassy. I don't know. I guess these are names. I don't know what those are. Used to create a lookup table that is created for the memory to improve processing speed. So queries are slow. Tables are faster. So we take a huge chunk of millions and millions of data from a table. You don't want to query that millions and millions of data. Bobbing it into another structure using PLSQL and just manipulate query the table. So, not bad. The table of records. So we have a table that can store multiple values that are referenced by a key. Usually used to store database records that need to be processed by the PLSQL program. So we're going to basically just store it in a native format. Improves performance by limiting the number of database retrievals. What we don't want to keep doing is going back to the database and retrieving stuff, which is our only option if we use another program. So. Okay, the most important feature is actually it has its own built-in exception handling. It doesn't really support very much else, actually. In fact, you've seen everything it supports so far. Exception handling is the last item on the list. All error handling statements are placed in the exception program block. So the code itself, when you're writing the program, and I'll revisit the structure in a few minutes, will show us how to actually add exception handling. We don't have this with SQL. There's absolutely no way to run an SQL statement with exception handling. So PLSQL gave us exception handling for SQL. Because now we run PLSQL, we can build in exception handling. If a query failed, we can turn around and change the query and run it again. And if that fails, we can run it again. Instead of having it to go all the way back, as what we don't want to do is query fails, goes all the way back to the application that connected to it. Nothing came back. Null. Why did it fail? Let's try it again. And the application just keeps trying over. It's not speaking. It's like there's a whole huge wall between the application and the database. They're not talking the same language. They're not communicating well. Exception handling from a SQL, PLSQL interface is better communication. So all the error handling statements are placed in an exception block. We'll see that in a few minutes. Exception handler is created just the same way it's done in other programming languages. Program command that provides information about the errors and suggests corrective actions. We have codes. Where else are you going to get a programming language interface that deals with Oracle exception codes? And for every one of you who have actually seen any of these, I don't think they put them out on the screen anymore. Earlier database versions of Oracle, I think it stopped in 8 or 9. I have to go check my current 11G version of it. It would say Aura-1005. And you'd be like, what in the world does that mean? And then you go online and you type in Aura, these thousands and thousands of reference books. In fact, when you buy it, if you actually buy this work, they give you printed copy. Well, they used to. I don't think they do it anymore. It was a complete waste of paper. You know, I'm talking bindings about 4 inches thick of Aura codes, Aura this, Aura that, and it's incredibly bad. So I think in the modern versions now it says missing something, or it's more human-like, and they don't give you the error codes anymore. However, you can take the error codes in PLSQL, use them as Oracle error codes, and have the exception handling take care of it. If this error comes out, because this error is going to come out from an SQL plus window, then do this. So common error codes that have given predefined names that appear instead of the error numbers also might appear. And you can use these as variables. So the exception name here might be a duplicate value on the index. So you can actually check for that. So this makes it easier to handle the errors when the exceptions do occur, so that you can actually do some error handling. And you're lucky if you get a result set that comes back to the application that's going to give you anything these days. Most of it's going to be empty. You're going to go, why is it empty? And then or you can do what the lazy people do. Select star, because they don't know what's there. And then they get more information than they could ever need coming back out of it, so that they can parse out the information to put it into whatever format they need to put it into after they can convert it, if at all possible. And it still shows up on the screen funny. It doesn't always show up correctly. So. All right, here's an example of how we implement the exception handling for predefined exceptions that are in. So here we have a language that actually supports predefined exception handling. When this exception name occurs, then do this. If this occurs, then do that. Common, very common, not unusual. Undefined exceptions, well, we can actually just take the code and create our own. So we can actually correct the errors that are coming back to the application through PLSQL by writing a program that takes and converts the exceptions to something that's more human readable, like missing file name, instead of Aura.1-29572, whatever. Less common errors that have not been predefined. Aura error code appears. Exception handling can be done to provide an alternative message that might show up. We have user-defined exceptions that we can also create with this. And some of the errors that will not cause a runtime error but will violate business rules. We can run checks on that, create user exceptions that actually come out that programs can create for custom error messages. Here's how it works. We have a nested PLSQL program here. We have an inner block and an outer block. Hopefully you can see that. Oh, good. It is kind of colored a little bit, but you can see the blocks at least. The outer block and the inner block. So the inner program block can be nested within the outer program block. And the inner program block here is doing some exception handling on a variable declaration, begin some statement, do some exception handling. Here we have a declaration of begin, do some program statements, and then do some exception handling out. So we can nest it, essentially. And when you nest it, it'll send the information back through the layers, which is great. Because, you know, if you're writing many queries, and you're writing a query, and then another, you're performing a transaction. If any part of the transaction fails, you want the whole thing to be rolled back. Because you don't want to go through and correct what failed. You just want to undo everything and start over again on the transaction. So this helps catch it if you put the exception handling in on the inner blocks. You know, nest the entire transaction, then you can actually kind of figure out how to do it, when to roll back. So exception handling is nested from program blocks, so that the exception is raised and handled in the inner block. The program execution resumes in the outer block after the inner block exception occurs. And here we have the exception is raised and handled in the inner block, and then the program resumes in the outer block. In fact, you can take and send the whatever information you want back and talk from the inner block to the outer block. feed something back. Exceptions raised in the inner box can be handled by exception handlers in the outer box. So this is how you do your transaction management, essentially, in a PL environment. That is, believe it or not, all of the features you may have ever wanted to know about PLSQL. And I know it was kind of, not really too bad for 60 slides, actually. I went through it at the speed of light. It is lecture slide set 5A. It's downloadable if you want to look at some of the syntax. However, I wouldn't spend too much time looking at this particular lecture. Instead, I'd go online and see what they've changed, because this is on an older version of Oracle. I know the language is still supported. However, it's not going to look the same. The interface is going to be slightly different. The commands are going to be different. The concepts are all the same, and I wouldn't be surprised if they didn't add more features to it, especially stuff for web-enabled applications these days, because that would actually kind of be a good thing. And it is part of the language that's built into their developer tools and some of their other packages, report generators and forms and stuff like that. Forms controls and stuff are all PL related. So it's their language, not supported by anybody else, hardly supported by them anymore. It's kind of, at one time they were phasing it out. I don't know what they're doing with it now, but one of the Oracle surprises, you know, to kind of learn about, essentially. So, any questions? Then we are done for today. Thank you for being quiet towards the end. I say towards the end. All right, see you next time.